Hey, I'm Laban Eilers. I work at SimpliSafe, and I'm going to do this talk about Observability 2.0. Let's see, I don't really know how to work this. That works, okay. So a little about me. I'm a sort of generalist developer. I did a lot of really early front-end stuff before Chrome or jQuery or things like that. Spent about 5 years ago, doing mostly engineering management. Discovered it wasn't really for me. Much happier back working on platform engineering, which I've been doing for maybe past 6 years, just hands-on. And I'm much happier this way. So I work for SimpliSafe. SimpliSafe, we may have heard us if you listen to podcasts or NPR or something. We sell security systems. What's kind of different about SimpliSafe versus a lot of other security systems is that our actual product is the outcome around security. We're not really trying to sell cameras. We're trying to sell safety in your home for your family. We have this really cool new product. Essentially, it's a service called ActiveGuard, where you have a camera mounted on the outside of your house. It's using AI to recognize the difference between the postman and your dog and the kids versus an actual intruder. And if somebody's there who's not supposed to be, one of our monitoring agents, a human professional monitoring agent, is going to start talking to them through the phone. At which point most of them run away. So it's an actual really effective deterrent against actual danger. So we have our systems all cloud-based, and we have many hundreds of microservices with probably in total many thousands of replicas across many regions. And I just want to assure my hosts at Grafana, I am going to talk about Grafana and why I love it. But there's a little journey involved. We're going to go on a little journey. All right, so Observability 2.0. Observability 2.0 is sort of a marketing hype term. Coined by Charity Majors, who, if you guys don't follow her, she's like a prolific blogger and thought leader, the CTO of Honeycomb, and just a fountain of insight on all kinds of stuff, not just observability, but engineering management and other stuff. I'd highly recommend following her. So yeah, the term Observability 2.0 was something she came up with. It very much describes Honeycomb, which you could understand. All that aside, I think it's a really useful framing and a way to think about what observability could be if we kind of started from scratch. So first, let's contrast it with Observability 1.0. This is Charity's definition. So this is centered around the 3 pillars. So logs, metrics, and traces. You really have like a lot of duplication between the different signals. You might have traces and logs representing the same events, or metrics summarizing the same events. And metrics is really kind of the workhorse of the Observability 1.0 paradigm. It's much more about monitoring, so knowing when things go wrong, than it is about sort of deep understanding of a system. And dashboards are probably maybe the most common symbol I think of, of Observability 1.0. So in contrast, Observability 2.0 is centered around the idea of wide events. So wide events you can think of, if you're familiar with logs, that maybe structured data like key value pairs. Traces are also considered wide events. You have a single source of truth. So I think in Charity's definition, it's like you actually have a single data store for all your telemetry. And in contrast with Observability 1.0, you have to ask, you have the ability to ask questions iteratively of your single source of truth. And the idea is that you understand your system's behavior much more deeply than you do just knowing when you're getting to error conditions. So yeah, in this model, you're taking a single data store, and then you can ad hoc ask questions that you didn't have to know the answer to, or you didn't have to know you were going to ask in advance, and you end up getting metrics out of these wide events iteratively. So, oops, went too fast. So, wow, this sounds amazing, right? Why would I want to pay to store my data 3 times? Why wouldn't I want to be able to ask ad hoc questions all the time? This sounds amazing, right? As with most things, there's trade-offs involved. So I'll discuss this in kind of 4 sections. The idea of metrics, that metrics are fundamentally a trade-off, the notion of sampling, the limits of the current state of tracing, and the maturity of the ecosystem, especially around OpenTelemetry. So metrics are a trade-off. So metrics are a series of measurements over time. So a metric is fundamentally an aggregate of a particular set, a large set of data. So instead of tracking individual events, a metric is a summary of all the events that happened in one interval of time over a long period. And a metric you can think of as a traditional metric. You can think of it as an answer to a specific question that you have to know you want to ask up front. So some example metrics: requests per second, the percentiles of a particular latency distribution, percentage of something that results in an error. Excuse me. So something that's fundamental about metrics is they have low cardinality. So, or to be useful, metrics have to have low cardinality. This is just a fundamental kind of physical limitation of time series databases. So time series databases are the most efficient way we know of to store metrics, and they work really well with low cardinality data. Not so well if you start adding very high cardinality fields. So for example, like a user ID, if you have millions of users, that means you're going to have millions of time series that have to be stored in memory in your time series database. So it's just not useful once you get to that scale with cardinality. But it's okay, because in metrics, you think about metrics in terms of big picture trends, not individual events. So you're looking at all the events that happened within 30 seconds, and give me some meaningful number that describes all those metrics. All those events. So just to illustrate kind of the difference between the Observability 2.0 and the Observability 1.0 model. In the 2.0 model, you have this single data store for wide events from which you can just ad hoc ask questions. Whereas with the more traditional metrics model, you're defining your metrics in code. You're writing some Go code that goes into your application that answers a question that you knew you were going to need the answer to upfront. Okay, so you're going to ask Laban, why would we ever use metrics? Like, obviously, the other solution is much more flexible, right? The answer is the cost discrepancy is ridiculous. Like, metrics are absurdly cheap when you compare them to the cost of storing high cardinality wide events. It's just a really compact representation. So it's a metric is just, you describe a metric with a set of labels and values, and that's just at the beginning of a metric. And then after that, it's just a series of numbers, right? So that's a very, very, very tight representation of a whole lot of data. There might be millions and millions of events that you're representing with just a series of numbers. So the trade-off is fundamentally one directly between cost and power. So just as an example, on the left we have a metric. We're going to talk about an artificial case here where we're measuring HTTP requests for a particular microservice. Let's say we got 10 pods. They're getting about 100 requests per second, so a total of 1,000 requests per second over the 10 pods. The things we care about: path, method, status code, stuff that you think about for an HTTP request. And if you take the combinatorial, you combine all those all those labels, you get, let's just say, 100 unique combinations in practice of actual label combinations. On the right, we're going to represent the same thing in a wide event. So this means we have effectively unlimited cardinality. We can store any data we want. but we're going to be storing every individual event with all of its data. So the difference, and I took here on the left, we've got, I think this is Grafana's list pricing for Mimir, for their metrics product. And on the right, I took Honeycomb's list price. I'm sure they'll negotiate better deals with you guys if you want. So you can see there's already a pretty tremendous difference, several orders of magnitude. And fundamentally, you're generating 1,000 spans, with span meaning a wide event per second. If you have 1,000 requests per second, you're generating 1,000 spans per second. With a metric, you're generating only the number of series you care about. So in this case, it was 100 series. Let's amp this up a little bit. Let's say we fixed some bugs, we got some performance profiling going on. Now we're able to handle 1,000 requests per second. In Honeycomb, my bill went up to 33,000 a month because I just 10x the amount of spans I was generating. But I still have the same 100 possible combinations of metrics. So I'm not paying a single dollar more. That's a pretty crazy trade-off. All right, and now I'll do a little plug for one of my favorite Grafana features, which is adaptive metrics. Adaptive metrics allows me to aggregate away labels I don't care about. So of those 100 metrics, maybe I don't care about the pod label. I just care about the metrics in aggregate across all my pods. So I've reduced the series down to 10 series instead of 100 series. So now I'm paying 80 cents a month, still paying $33,000 a month if I was doing some wide events. And you're going to say, Laban, this is a totally contrived example where there's no way this is reality. It really is. In SimpliSafe, we have all three. We're utilizing all three pillars, and there is indeed an order of magnitude cost difference between metrics, in this case traces. But as you remember, it's the trade-off. We are giving up something. Of course, if I could use wide events for everything and I could afford that, awesome. I would also love to only dine in Michelin star restaurants, but that's just not in the cards for me. So how does anyone actually afford wide events? The answer is sampling. So I mean, I guess there comes a time in the lives of many platform engineers where you might have some uncomfortable feelings, some new feelings about your observability build. You might want to engage in some risky behaviors like statistical sampling. But I don't want to shame anyone. This is a normal and healthy behavior. So statistical sampling with traces, you generally have a system that intercepts all the traces you're generating across your system. And then it's kind of statistically samples, say, in our case, we sample about 1 out of every 30 traces that go through the system. And then this is a pretty cool feature of Honeycomb. I don't know if Grafana does this. I hope they do add it if they don't. But it does statistical extrapolation at query time. So you're looking for a particular event that happened over a period of time, and it'll say, oh, well, I've only got 1 of these, but I'm going to multiply the value that they're looking for by 30. So it's pretty opaque to you as an end user, and you just get a sense of the real values. And this is built into OpenTelemetry. Yeah, sorry, OpenTelemetry has the primitives that make this possible. So they have things like the sampling ratio as a property of the events. I feel like the person that this happened to with me is maybe in this room at this point, but I was at another Grafana event, and I was talking with someone about Honeycomb, and they learned they use Honeycomb, and without thinking, I kind of blurted out what's your sampling ratio? And then the table went quiet, and I was a little afraid I'd made a faux pas that I wasn't aware of. So I apologize to that person if they're in the room, if I made you uncomfortable. I can't possibly divulge this in confidence. So there are some challenges with sampling. It is a really powerful tool, but it has a ton of moving parts. You have notions of head sampling versus tail sampling. In head sampling, it's like the producer of telemetry has to decide what to sample. With tail sampling, you're waiting until traces come from all your different sources and get assembled into a larger trace. And then you make decisions about sampling. Much more powerful. And in practice, that's really what you want to do, but it's really complicated. You need a lot more infrastructure to make this all happen. There's a lot of things that can go wrong on the way to doing the actual sampling decision. And because you're doing statistics here, there's a margin of error. And if you're a person asking questions, you don't know enough about statistics, you might not be able to judge how accurate the answers really are. And this is maybe more of a question of like human techno-social systems, but one programmer can, because of the nature of traces flowing through multiple systems, one programmer can make a mistake in one system that flows all the way downstream, and you end up with wacky answers to queries downstream. And this has probably been the hardest thing for us personally at SimpliSafe, that we have a lot of these use cases for observability that are sort of like forensics. We have a particular security camera that didn't do something right, didn't log in, or a video frame got dropped or something. We want to go look at logs for that thing. In the case with these sampled traces, when we're sampling away 29 out of 30 traces, the odds are it's not there anymore, right? So we just can't rely on traces for these kinds of use cases. And luckily, this hasn't happened to us. I say luckily, but we take security very seriously, obviously. But if we were trying to investigate an actual incident where we had a breach or something, could you imagine trying to do that with sample data on your security audit logs? You really need 100% of those logs. So overall, sampling is an incredibly valuable tool, and it allows us to afford tracing. And tracing, I mean, if you guys haven't actually used it, is an incredibly valuable tool for understanding a big distributed system. It's hard to imagine how we would solve a lot of the kinds of problems we have without it. And sampling makes it affordable. But I think the caveat is you need something to corroborate the answers you get, because they can be wacky sometimes. And you know what's great for corroborating traces? Logs and metrics are fantastic because you're doing the calculations in completely different sets of data. You have a lot more confidence that you're getting the right answers. And there's some other just limits of tracing at the moment. Maybe these are all solvable, but right now, in practice, they really are a challenge. A big one is third-party code. So if you're running a Kubernetes distribution and you have a whole bunch of system components, odds are they're producing metrics and logs, but not traces. So you just won't have a lot of visibility into those if you're relying fully on traces. Long duration events that are more than, say, a minute and a half or two are just sort of an unsolved problem in tracing, in OTel in particular. Sorry?
You said longer than how much?
I'd say like between a minute and a half and 2 minutes. Yeah, I mean, because like your traces come into a system that's going to do sampling or aggregation on them, and it has to batch them up, and you don't want telemetry data behind more than a minute or two, right? Another is if you have an asynchronous system where you have different processes that have, say, message queues or something in between them, and they're not actually linked by a request ID or something you need to correlate trace. It's really hard to actually follow a trace all the way through a bunch of asynchronous processes. And then there's just really basic stuff like an application crashes. Traditionally, we'd get the stack trace or something, or the memory dump or something in a crash report in logs. With tracing, the tracing is usually done inside the process itself. You usually have an SDK installed in the application. And when the app crashes, all that state that you've been building up is gone. So it's really hard to debug a crash via traces. And then there's just things where it's not technically impossible, but it's not a great modeling fit. It's hard to model things like background processes, startup and init events and stuff in terms of traces, because they're fundamentally about a series of like linked requests, not about individual events that happened. And then just in practice, we've had our fair share of foot guns regarding tracing. Graceful shutdown is really important to get right, because as I mentioned, tracing is sort of accumulating telemetry state as you go, and then flushing it at some interval. And if you're shutting down when you still have state to flush and you didn't do your graceful shutdown properly, you're going to drop spans, and then you end up with indecipherable traces. There's also, we've found and sometimes fixed a number of context propagation bugs. Traces really require context to link between different systems spans. And there was this one nasty one there's a Node.js library called Bluebird, which we had been using for a long time. And it was ultimately discovered it was the source of context being dropped across async tasks in Node.js, and that was a source of a whole lot of pain. We finally figured all this out. We've got it working nicely now. And then there's the overall maturity of the ecosystem. So Honeycomb did approach us about going all in on Observability 2.0 and replacing everything with traces. And we had already had some of the experiences we had talked about with tracing and had a sense that generally the ecosystem wasn't ready for it. And in kind of gathering the context across, gathering the opinions of like my colleagues and some folks from Grafana gave us some pretty good tips on this. They pointed out the virtues of some of the more traditional, the two more traditional pillars. So logs are everywhere. They're produced by everything. They're rich and high cardinality. You can query the heck out of them. The developer experience for logs is amazing. You do printf and you get a log in your terminal and you can grep it or whatever you want. And this stuff has been going on since the dawn of computing, right? Like logs, everybody knows how to use logs. And as we've learned, metrics are not only simple and ubiquitous, but absurdly cheap. Like when you compare them to comparable events, they're very efficient and fast, not just at query time, but when you're in your actual application, producing spans and logs is a lot more expensive in terms of memory, serialization, compute time, network than metrics, because metrics are just sending a number every 30 seconds or so. And just the reality of the situation is, if you look across mature industries in the world, manufacturing and telecommunications stuff, they all run on metrics. Like this is a problem we've solved around when you're talking about monitoring known infrastructure that like we understand its behavior. You cannot beat metrics for cost effectiveness. Okay, so all that said, I still think Observability 2.0 is a really interesting North Star, and it's a pretty compelling vision if you're not bringing black and white thinking to it. I think it's something that we can sort of think of as a target we can move towards incrementally. And instead of thinking very literally about Charity's description of it, I'm sort of thinking about the outcomes she's describing rather than the implementation details. So I think I'm thinking of these in these three categories. So affordability, the cost difference between a time series database and these wide event databases, I think it's fundamental to the data structures. It's not something we're ever going to be able to completely make it go away, but we can probably narrow the gap a lot more than we are. There's already been a ton of progress in that. Oops. I don't even have Adobe. What is this? oh, sorry. I'm getting an error message on top of my. Oh, this is your machine.
That's my machine. Yeah. Sorry.
There we go. It's like popped up an Adobe thing. And just a caveat, like I'm talking about wide events being an expensive source. I'm just going to compare. I don't want to name names, but like compared to certain dominant rent-seeking observability vendors. And like something like Grafana or Honeycomb is not that bad at all. And there's a lot of really cool stuff going on in open source around, in particular around columnar datum stores, which seems to be a really amazing product design pattern kind of that comes out of analytics products. We've been using this. I mean, this has been around for many years, but it's sort of making its way into the observability space. There's these open source products like the Apache Parquet format, ClickHouse, which is an analytics database, which is beginning to be used really successfully for observability, and Grafana Tempo, which I believe is a columnar data store of its own. This is Grafana's tracing product for those who haven't used it. So the developer experience for OpenTelemetry is still a little bit rough. We've gone through it, the whole journey, and we're in a good place now. But it was a little painful, a little trauma. But there's a lot of things you can get wrong, like all those dropped spans and things like that. But just in general, setting up the SDKs it takes some fortitude in your applications. And instrumenting for us, 150-ish microservices is a big lift. But all that said, I just want to say, if there's any OpenTelemetry contributors listening, I love you guys. You are doing God's work. OpenTelemetry is the future. I have no doubt. I think of OpenTelemetry as like where Kubernetes was 7, 8 years ago. It's like, obviously, it's the solution. It's the future. We just have to work together to get it there. So I love you guys. So finally, there's the ecosystem, just the reality of the state of the ecosystem today. The third-party infrastructure, like all these Kubernetes components and things that mostly emit logs and metrics today, that's changing gradually. Like there are some new OTel-enabled things happening especially in the Kubernetes world. The fact that tracing doesn't address all the use cases you can handle with logs, like crash dumps and things. Overall, I sort of think of this as that the ecosystem is ripe for a bunch of new innovation that can solve all kinds of usability problems. So, like if you've ever used the Prometheus operator, like you install it with a Helm chart, and it just works. It's amazing until you get to a certain scale, but it works great. It's super easy from a developer experience perspective. I really want to see like more OTel stuff that works that easily, and I'm sure we'll get there, but I think we're not quite there yet. And there's a ton of amazing stuff going on with eBPF, like Grafana Bela. There's other products too. I haven't used them. I would really like to. I wish I had them like 3 years ago, because they might have saved me a lot of time having to configure OTel SDKs. But I think it's ripe for like some really incredible innovation. So I think we want to thinking about outcomes rather than the actual implementation details for Observability 2.0. The thing that's really cool is the ability to ask ad hoc questions and not have to be stuck with the questions you knew you were going to ask when you wrote the code. That's the outcome we want. And I think there's other ways to do it. One of the main ways is I think tools that take the 3 pillars and integrate them really seamlessly is just a much more practical solution than trying to throw away all the history behind logs and metrics. And it's a way that we can incrementally move to more dependence on richer data sources and maybe less on metrics, but still have the bridge to the past. And then just utilize the pillars for their strength. And you can also kind of shift your dependence when you have that kind of system. You can shift your dependence away from maybe like as you learn, the system becomes more mature and there's not much active developing going on, can shift more of the observability load into metrics where it's a lot more cost effective. And then stuff where you're doing tons of active development, you've got like a really distributed system, shift more of your energy into traces where you can deeply understand the behaviors of your systems. And that way to manage costs can be incredibly effective. And so let me just point out what the system I just described, where you can do all these things and you have the power of those trade-offs. I think Grafana Cloud does this really well. This seems, I mean, I've never talked to anyone about this idea specifically at Grafana, but it seems to be like they're the way they're heading. All these new types of richer applications beyond what you can do just with dashboards that are integrating signals and allowing you to use exemplars to hop between metrics and traces, having dashboards that combine signals, being able to build alerts that combine from different data sources. This stuff is actually really, seems to be really happening inside Grafana, and the architecture seems to work really well for it. That is it.